All right, so in this one, we're asked to solve, to find the three numbers. And this one, again, is similar to number 8 that's in section 6.3. Excuse me, in section 6.2. All right, it says three numbers sum up to equal to 112. All right, so we're dealing with three numbers. The smaller number is 1/4 the larger number, and the middle number is half the larger number. We're asked to find the three numbers. Okay, so the first thing we're going to do is set up some variables. So what I mean by setting up variables, we have three numbers, and the way that this is set up, we have a smaller number, a middle number, and a larger number, right? So I'm going to call the smaller number S. I'm going to call the middle number M, and I'm going to call the larger number L. All right, so you call them X, Y, Z. Okay, you can pretty much give them any letter of the alphabet you want, but I'm going to use S, M, and L, okay, for short for smaller number, medium number, and larger number. So if we kind of look at this, this is giving us three statements. The first statement says that the three numbers sum up to give us 112. So that means if we were to add the smaller number plus the middle number plus the larger number, that should equal to 112, and that is actually an equation. Just remember, wherever you see is synonymous with the equal sign. All right. So now if we look at this second statement, it says that the smaller number is 1/4 the larger number. So I'm going to write that out as an equation. Just remember that is an equal sign, so it says the smaller number, which is S, is equal to, that should be 1/4 the larger number. So S is equal to 1/4 of L. And then we have our last statement. It says the middle number is 1/2 the larger number. So the middle number equals to 1/2 the larger number. All right, so we actually have three equations. Okay. Now, before we can put these into the calculator, just keep in mind that we're going to have to convert this to a matrix. So notice that we have three variables, S, M, L, and then we have whatever it's set equal to. So we're going to have a matrix that's 3 rows and 4 columns. Okay, so we're going to convert this to a 3x4. But before we convert it to a 3x4, we just want to make sure that all of our variables are on the same side of the equation. Okay. So this is what I'm going to do. So our first equation, that's going to stay the same. S plus m plus L is equal to 112. For that second equation, I have to get all of my variables on the same side of the equation. So for this second equation, I'm going to take S, and I'm going to subtract S from both sides of the equation. All right, so I'm going to have something that looks like this. Negative S plus, well, I'll leave out that. Negative S plus 1/4 L is equal to 0. All right, so actually what I did was I took S, I subtracted S from both sides. So on the left-hand side, I get 0. And I kind of flipped it around. So I have negative S plus 1/4 L equal to 0. And I'm going to do the same thing to that last equation. I'm going to take M. I'm going to subtract M from both sides. So I have negative M plus 1/2 L is equal to 0. So the key thing here is you want to make sure that all of your variables are on the same side of the equation. So now once we've got all our variables on the same side of the equation, we're going to convert this to a 3×4 matrix. All right, so we're going to pull out the coefficients. So for that first equation, I should have 1, 1, 1, and 112. For that second equation, we're going to have negative 1. Since I don't have an M, okay, I'm going to put in a filler term. So I'm going to put in 0. And then we have the coefficient of L is 1/4, and that is set equal to 0. And then for our last equation, we don't have S, so we're going to put in a filler term of 0. The coefficient for M is negative 1. And we have 1/2 for L, and that is set equal to 0. All right, so we're going to put this in the calculator as a 3×4 matrix. So I'm just going to clear that out. And I'm going to go over to edit. So I'm going to put in the coefficients. Well, we'll change up the dimensions, 3×4. And just remember, you want to hit enter after every entry. So we have 1, 1, 1, 112. Negative 1, 0, 1/4. So I can put in 1 divided by 4. And the calculator is going to reduce that down. And we have 0, and then 0, negative 1, 1/2, which is 0.5, and 0. So let me check that really quick. see, 1, 1, 1, 12, negative 1, 0, 0.250, 0, negative 1.50. Okay, so I have the correct elements in. So now I'm going to calculate the solution. So I'm going to go, first off, I'm at the home screen. I'm going to go back into matrix. I'm going to scroll over to math. I'm going to scroll to RREF. I'm going to put in matrix A. Okay, I should put in RREF, not REF. So that's math. Oh, my goodness. All right, and we have the 6 numbers. So again, on how we interpret this, one zero 0 16 0 1 0 32 0 0 164. Right. So we're going to read that first row. That's an equation as x is equal to 16. That second row is, or excuse me, s, right? Because we set our variables s, m, and l. So s is equal to 16. M is equal to 32, and P is equal to 64. So we have the ordered pair solution 16, 32, and 64. So if you add all 3 of those numbers up, they should equal to 112. All right, we're also going to take a look at this one. All right. Okay, so let's take a look at this one. Okay, so it says at a family reunion, there are only blood relatives consisting of children, parents, and grandparents. There were 125 people total. There were twice as many parents as grandparents, and 25 more children than parents. How many children, parents, and grandparents? All right, so here again, we're going to set some variables. So we're going to let the children equal to C. We're going to let the parents equal to P, and the grandparents equal to G. And so we're using C, P, and G. Okay. So just like in the last problem, we're just going to break this up into 3 equations, right? So there'll be another 3 by 4. So it says there were 125 people in total. So that means that the number of children plus the number of parents plus the number of grandparents was 125. Okay, so that's our first equation. The second equation says there were twice as many parents as grandparents. Okay, so there were twice as many parents as grandparents. All right, so that means that the number of parents is going to equal to twice the number of grandparents. Right. All right, because there were twice as many parents as grandparents. So if we take the number of grandparents, multiply that by 2, right? That will give us the number of parents. And the last says that 25 more children than parents, right? So that means that the number of parents plus 25 that would equal to the number of children. So we have our 3 equations. All right, so we're going to set this up into a, first of all, we're going to get all of our variables on one side of the equation. So we have C plus P plus G is equal to 125. So now it really doesn't matter which side of the equation you put all your variables on. Like in the first problem, I kind of put everything on the right-hand side. All right, here you can kind of put everything on the left-hand side or the right-hand side. You just want to make sure when you move elements across the equal sign that you change your sign. All right, so here I'm going to subtract P from both sides. So I'm going to have negative P plus 2G is equal to 0. Okay, and then for this last equation, P plus 25 is equal to C. Now keep in mind that 25 is a constant. So I'm going to subtract C from both sides. So we have negative C plus P is equal to negative 25. Because 25 is a constant, and the only thing I want in this case on my left-hand side are the variables. All right, so we're going to convert this again to a 3x4 matrix. So we're going to list out the coefficients. So we have 1, 1, 125 as our first equation. So remember, we're going in the order of C, P, G, and then equal. For the second equation, I don't have a C, so I'm going to put in a field of 0. P has a coefficient of negative 1. The number of grandparents in that second equation is 2, and that's set equal to 0. And then for our last equation, we have negative 1 for C. We have 1 for P. We're going to put in a filler 0 for the number of grandparents, and that's equal to negative 25. So we're going to put this into the calculator. Second matrix. All right, so this is 1. 125, 0, negative 1, 2, 0, negative 1, 1, 0, negative 25. Right, so let me just check the matrix. Okay, 125, 0, negative 1, 2, 0, negative 1, 1, 0, negative 25. All right, so that looks good. So now I'm going to calculate the solution. So I'm going to go back in the matrix. Under math, we're going to find REF. Okay, I'm going to put back in matrix A. All right, and we have and again, I'm going to use REF. All right, and we have the reduce matrix. So we have 1, 0, 0, 65, 0, 1, 0, 40, 0, 0, 1, 20. So we have that first equation as C is equal to 65. P is equal to 40 for the second equation. G is equal to 20 for the last equation, which gives us our ordered pair solution of 65, 40, and 20.